All right. So we are about 8 hours from landing the biggest, baddest rover ever built on the surface of the red planet. Is that amazing or what? Wow. Wow. Just incredible. Space, am I nervous? No, not at all. Don't have time to be nervous. That's the good part. Stay busy, stay busy. So the spacecraft, just quickly, is doing great. We're about 100,000 miles out. The gravity well of Mars is tugging on MSL now. It's accelerating from where it was at about 8,000 miles an hour this morning. And by 10 o'clock tonight, we'll be about 13,000 miles an hour, about to then attempt to slow it down again. So things have been going great. Spacecraft's in good shape. We had a trajectory correction maneuver we were thinking about tonight. We're not doing that. The navigating team has done an amazing job. We were right down the pipeline. So everything is good. In fact, I'm not sure they're even going to send any more commands to the spacecraft at this point. Things are going so well. So I think it's on its own, it looks like, at this point. So that's great. You'll hear more about the spacecraft, about entry, descent, and landing, things like that from Rob Manning in a couple of minutes, and then Matt Gollenbach will talk to you as well. I want to set some context for you at the very top level and tell you why we're doing this and what we're doing here. If you hit the first one. So the fact that we're sending this rover is not an accident. It's not a coincidence. It's not just a bunch of guys and gals in the back room who said, let's go fly something really big. It's a methodical process and a methodical program of exploration at Mars to understand, you've heard follow the water, to understand the water processes and the water history of this planet and try to figure out some of the early questions to help us figure out if we are alone in the universe. Mars has a great potential for helping us with that. MSL is the first astrobiology mission since Viking to really help us with that. Going down to the bottom of Gale crater, which I'm going to show you in a minute and show you why that's so exciting. The ability to get into Gale crater, however, is because of the previous missions. You see Mars exploration rovers up there, you see Pathfinder up there, and Viking just was a huge landing ellipse. We have taken that and we have shrunk our way down to a 6 by 20 kilometer circle of uncertainty on the ground, which is really, really tiny. Thank you. Now all I got to do is hit the right button. So it has been an extremely methodical process scientifically, but also technically to get MSL where it is. This is where we're going. Gale crater, kind of an insignificant looking crater from here, right? A little dot on the side of the planet. But when you get right down to it, right, this is an amazing place. It's 96 or so miles in diameter. It's got a 3-mile high mound in the middle of it that's a sedimentary layer. That we believe that thing was filled in. I'm probably getting into Matt's area, but we believe that was filled in at one point and is eroded away. What it's left us is a mound that's several times taller than the Grand Canyon is, that will take us from modern day Mars at the top all the way down to ancient Mars. Can we get back 3 or 4 billion years in this sedimentary layer? We hope we can. And then we've got some other amazing things here. The reason we want to go on the bottom of the crater, not only is it a little smoother to land in, we can squeeze ourselves in there, but this is what we see in our landing area. This alluvial fan structure you see is kind of a purplish and light blue color. Looks like a water runoff from the side of the crater wall down into the crater's lower extremity there, and has fanned out kind of how water does in deltas like New Orleans and the Egyptian Nile and things. Laying sediments down, laying materials down, that we want to understand what that is. We don't know how old that is either. So we don't know whether that goes underneath the mound in the middle, Mount Sharp, or whether that actually lays up on top of that mountain, which would also be very interesting to find out. The clays and the sulfates you see listed here are extremely important. Those tell us it's had a rich history of water in the bottom of this crater. Hopefully, and this is what we're going to try to find out, hopefully one of the places on the planet that may have been a habitat for life at some point in history, could be now even, don't know, we'll find out. And then all kinds of things we don't understand. These cemented fractures, some of this younger strata up there that actually has some really interesting albedo characteristics to it that we don't even understand what it is. So the history of Mars is in this hole, if you will, in this deep crater that was punched in the surface billions of years ago, filled in and eroded away again. Unbelievably exciting scientific place to go, unbelievably challenging technical place to go. but there is an amazingly talented team at JPL that has built this thing for us, that's driven this thing to the planet for us, and is going to put it down in that little spot tonight at 10:30. Now, this is obviously an artist concept because Opportunity and MSL are a little too far apart to do this and follow each other around, but it makes a really nice picture. So, tonight at 10:30, I hope you'll all be glued to your seats, watch what's going on, and don't walk away. Once we land, don't run off, because the next Odyssey pass is at 12:30 Pacific time in the morning, and if we aren't able to get any images down, and they're not real likely, at the landing time, we're hoping that we'll get some imagery down from the hazard cameras in the front and rear of the spacecraft of the rover at that 12:30 pass. So you too can see where Curiosity is on the surface. You see the wheel sitting on the dirt, and that's a pretty exciting thing to do. The culmination of years of effort, 37 states, thousands and thousands of engineers, 12 different countries. We're going to that hole in the ground on Mars tonight, and you guys are coming. Thank you.